Alrighty, boys and girls, welcome to our fourth video lesson in Unit 1, our unit on linear inequalities. This is on linear programming. Alrighty. Alright, boys and girls, let's talk about what a linear inequality is. A linear inequality is just like a linear equation, but the equal sign is replaced with an inequality symbol. And we'll be dealing with lines here, so it's like y equals mx plus b, or y is less than mxb, or y is greater than or equal to mx plus b, or in any other form, like general form. The solution of a linear inequality is any ordered pair that makes the inequality true. So let's just look at this first inequality right here. 3x plus 4y is equal to 8. Let's look at the ordered pair 1, comma 1. 1, comma 1 would not be a solution of this inequality because x is 1, 3 times 1 is 3, y is 1, 4 times 1 is 4, 3 plus 4 is not greater than 7. So therefore, the ordered pair 1, comma 1 was not a solution. However, if I had the ordered pair 5, comma neg 1, for example, 5, comma neg 1 would be a solution because when I throw in my x is 5, 3 times 5 is 15, plus 4 times y is negative 1, 4 times negative 1 is negative 4, 15 plus negative 4 is 11, 11 is greater than 8. So you guys right now, stop the tape, and figure out which ones, or if any, which one, or more than one, which of these ordered pairs, A through D, are actual solutions to this inequality. Have some fun, go. Okay, you should have found that the first one, A does not work because you get 3 times 6, 18. 18 plus 4 times negative 3 is neg 12. 18 plus neg 12 is positive 6. 6 is not less than 8. For B, you should have found that it worked. 3 times neg 3 is neg 9, plus 4 times 5 is 20. That's positive 11. 11 is greater than 8. 4, comma neg 1 does not work. 4 times 3 is 12, plus 4 times neg 1 is neg 4. 12 plus neg 4 is 8. 8 is not greater than 8. So therefore, that one did not work. And D, sorry, we just did it. I should have looked ahead. But D, we just did it. D did work because 3 times 5 is 15, plus 4 times neg 1 is 11. 11 is greater than 8. The graph of a linear equality is a set of all the points in the coordinate plane that work. In other words, we're going to be shading one side of the line or the other. So we'll be graphing the lines and shading one side because one side of the line is going to work and one side of the line is not going to work. So your steps to graphing a linear inequality or solving a linear inequality through a graph is solve the inequality for y. In other words, put the inequality in mx plus b form. Decide if the line is solid or dotted, and then you look down here. It's a dotted line if we have less than or greater than. It's like an open dot. So a dotted line is like an open dot. If it's equal to, greater than or equal to, less than or equal to, or greater than or equal to, it's like a closed dot. That's a solid line. Okay, so we decide the line is solid or dotted, then we graph the line, and we choose an ordered pair to decide which side to shade. Your ordered pair is 0, 0, as long as the line does not pass through 0, 0. The easiest pair to check with, to test, is 0, 0. And you'll see what I mean right now. Okay, we're going to solve this one right here. Y is greater than or equal to 2x plus 1. First step is to put it in mx plus b form. It is. Y is equal to 2x plus 1, or y is greater than or equal to mx plus b. So we're going to graph that line. I have a y-intercept of 1, and I have a slope of 2, so it looks somewhat like that, right? And 0, 0, just so we know, 0, 0 right there is a little bit to the right of that line. The line does not pass through 0, 0. So I graphed the line with a solid line, and the reason I graphed it with a solid line is because of the equal sign, greater than or equal to. If that had been just greater than, it would be a dotted line, but it's a solid line. And now we're just going to test to see which side I shade. Do I shade to the right or do I shade to the left? And I'm going to plug in the ordered pair 0, 0. If 0, 0 works, I'm going to shade this side. If 0, 0 does not work, this side doesn't work, which means I'm going to shade this side. So let's see. 0, 0. Let's plug in the point 0, 0. Let x be 0. So y is 0. X is 0, so 2 times 0 plus 1. So I'm going to ask ourselves now, is 0 greater than or equal to 2 times 0 is 0 plus 1. 0 plus 1 is 1. Is 0 greater than or equal to 1? The answer to that is no. 0, 0 did not work. So therefore, the 0, 0 sign to the right of that line doesn't work. So I'm going to shade everything to the left. And that means now that any ordered pair in the yellow region, any ordered pair would work for this inequality, and any ordered pair not in the shaded region is not going to work in that inequality. All right, let's try this one. First of all, this is not in mx plus b form, so I'm just going to minus 2 from both sides to put it in slope intercept form. So now I'm going to have y is greater than 1/3 x minus 6. Whoop. I now decide, is this going to be a dotted line or a solid line? This is going to be a dotted line because I have a greater than sign, but not a greater than or equal to sign. It's just a greater than sign. So I'm going to have a dotted line at y equals 1/3 x minus 6. So I'm going to do that right now. I'll do that in red. I'm going to go down to 6. It's right here. I have a slope of 1/3. I have a dotted line passing through all those. That's a dotted line, folks. Dot, 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 dot. And now I'm going to decide, do I shade? Do I shade everything up here? Or do I shade everything down here? And I'm just going to throw in an ordered pair. The easiest ordered pair I'm going to plug in is 0, 0. So I'm going to plug in 0, 0. I can plug it in back to the original, or I can plug it in here. Let's do it right here. That's probably just as easy. So I'm going to let y equal 0 is greater than 1/3 x is 0 times 0 minus 6. 0 is greater than 1/3 times 0 is 0 minus 6. 0 minus 6 is neg 6. Is 0 greater than neg 6? Yes, it is. So therefore, I'm going to shade everything in the region that includes 0, 0. If 0, 0 didn't work, then I would shade everything down here. Okay, that was pretty easy. So let's talk about solving a system of linear inequalities. That's going to have two inequalities, and it has to meet both inequalities to be part of the solution. So all we're going to do is graph both of these things and shade as we did before for a single, and just find the overlapping region. For example, in this first one right here, we have one line, and it looks like we're shading everything below that line, or to the kind of right of that blue line right here. We also have a red dotted line right here, a red dotted line. It looks like we're shading everything to the left or below that line as well. So our region that overlaps, that meets both criteria, is this wedge right here, and of course this goes forever, but it's this triangular piece right here that meets both criteria. In this example, we have a red solid line. It looks like we shaded everything to the right, or I'm sorry, to the left of that line. We had a blue dotted line right here. Looks like we shaded everything to the right or below that line. Our region that meets both criteria is this little wedge right here. Okay, so any point inside that wedge is a solution to the system, and any point not in that wedge is not a solution to the system. Okay, let's look at this example right here. I got two inequalities. Negative 3x plus 2y is greater than or equal to 2, and y is less than 4x plus 3. Let's look at the first one. That is not in slope-intercept form. So the first thing I'm going to do, just to make my graphing easier, is I'm going to write that in slope-intercept form. And do you agree I can add 3x to both sides? So I'm going to get 2y is equal to 3x, is greater than or equal to 3x plus 2. Divide both sides by 2. Don't forget, if we divide by a negative, to flip-flop that neg. But I'm also going to have now y is greater than or equal to 3 halves x plus 1. So my red line is going to have a y-intercept of 1. It's a solid line with a slope of 3 halves. It looks something like this. Let's decide if we're above or below. Let's throw in the point 0, 0. We can throw it back into the original, or we can throw it into my y equals mx plus b, whichever one you prefer. Let's throw it back into the original. What's neg 3 times 0? 0, very good. What's 2 times 0? 0, very good. What's 0 plus 0? 0, very, very good. Is 0 greater than or equal to 2? The answer to that is no. So 0, 0, the ordered pair is 0, 0. The origin, the easiest point to throw in, didn't work. So I'm not going to shade on the side with 0, 0. I'm going to shade on the side without 0, 0, and I'm going to do that in red, just real quick. I'm now going to do my other line. I'll do that in green. That was y is less than or equal to 4x plus 3. So I'm going to go up to 3. I have a slope of 4, which is steep. It looks something like this. Rough sketch here. Notice that 0, 0 is not on the line. It's a little bit to the right of the line. So I can throw in the ordered pair 0, 0. So I'm going to do that right now. 0 is y is less than 4 times 0 is 0. 0 plus 3 is 3. Is 0 less than 3? The answer is yes. So therefore I'm going to shade everything where 0, 0 worked. And I need my green pen, sorry. That region, it works for the green line. Now, I did make one mistake. Probably all of you are screaming at me. In fact, I'll give you a bonus point if you email me my mistake. I know exactly what I did. It has to do with my line. It has to do with my green line. But any which way, email me if you've noticed my mistake. And now my final answer is going to be, I'll do it in yellow, is going to be this wedge right here. And I'll give you another clue right now. Half of that yellow wedge is dotted and half of it's not. Okay, so my region of overlap is right here in yellow. And that's the only way to really express that answer. So, down here, name 2 points that are solutions. For example, we could name the ordered pair right here, 4, 10. We could name the ordered pair right here, which I think would be 2, 6-ish. And now we can name 2 points that are not solutions. Anything down here, 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 here. You can name any that's not inside that wedge. Alrighty. Okay, let's try this guy. I have 3 inequalities, a system of 3 inequalities. Y is greater than neg 2. X is greater than neg 3. And 2x plus 3y is greater than 3. So I'm going to do the first one in yellow. Y is greater than neg 2. So I'm going to have a dotted line. That's a dotted yellow line at neg 2. It's hard to draw it dotted, but that's a dotted line at y is negative 2. And it's everything, if you want, above. Then I'm going to have, I'll do this in green, x is greater than -3. So I'm going to have a vertical dotted line at -3. It's hard to draw this dotted, but there it is. I have everything to the right of that line because x is, so far I have this region, if you want to think about it, I have this region right here, right? This quad, this little rectangle, okay? And now I'm going to take my third line, we'll do that one in red. I'm going to put it in mx plus b form first by subtracting 2x, so I have 3y is greater than -2x plus 3, divide by 3, divide by 3, divide by 3, y is greater than -2/3 x plus 1. So I have a y-intercept of 1, a dotted line at -2/3 x, so here, here-ish, here, I have a dotted line, and it's everything below that line, and I know that because it's everything above that line. But let's plug in the ordered pair 0, 0, see if it works. 0, 0 is below that line. So if I plug in the ordered pair 0, 0, I get 2 times 0, 0, plus 3 times 0, 0, 0 plus 0 is 0, 0 is not greater than 3. So therefore now, I'll do this in black, my region is going to be everything greater than x is 3, everything greater than y is 2, -2, I'm sorry, and everything above this red line, so it's this shaded little wedge right here. Go ahead and choose 2 points that are solutions and 2 points that are not solutions, and fill in your answers. Okay, you guys try this one by yourselves. It's a system of 4 inequalities. You have 2 vertical lines, x is greater than 1, x is less than 3, y is a horizontal line, y is less than or equal to 0, and we also have x minus y is less than or equal to 6. Put this first one right here in slope-intercept form. So, go ahead. Okay, you should have found for your final answer is this yellow region right here. It's bounded by these 2 vertical lines, the horizontal green line, and this diagonal line, y equals x minus 6 right here. Okay, so our region of possibilities is bounded right here. Let's figure out why. Let's start with the vertical lines. X is greater than 1, so yes, this red line should be dotted. That's a dotted red line, and it's everything to the right of that. But likewise, x is less than 3, so we have a dotted line. That's dotted. And everything is to the left of that. So far, just with the vertical lines, we have a region of possibility in between those 2 red lines. Y is less than or equal to 0, so I have a solid green line at y equals 0, the x-axis, and it's everything below that. So at just those 3 lines, I'm going to have this region of possibility right here, this little stripe below the x-axis between the 2 red lines. But then I also have y is greater than x minus 6. When you took this first equation, solve it for y, yes, you need to flip-flop the sign. Y is greater than or equal to x minus 6, which of course is this line. It's a solid black line. And you throw in 0, 0. 0, 0 does actually work. So it's everything above this line. So that's why it's just this little chunk right here. Okay, here's why we learn how to solve and graph these inequalities. We're going to do some linear programming. Let's look at this first problem. We'll do a lot more of these in class, don't you worry. Abby is buying plants and soil for her garden. The soil costs $4 per bag and the plants cost $10 each. She wants to buy at least 5 plants and can spend no more than $100. Write and graph a system of linear inequalities to model this situation. What are the unknowns? Let's let x equal the number of bags of soil. We're going to let y equal, what do you guys think? That's right, we're going to let y equal the number of plants. So, the inequalities, is going to be, what does it say? She wants to buy at least 5 plants. So Y has got to be greater than or equal to 5. Well, X, the number of bags of soil, she can't buy a negative number of bags of soil. So X has got to be greater than or equal to 0. And lastly, we know she can spend no more than $100. And the bags of soil cost $4, and the plants cost $10. So, I'm going to write my other inequality up here. I know that 4 times the number of bags of soil I buy plus 10 times the number of plants I buy has got to be less than or equal to 100. Because the amount of money I spend on bags of soil, dirt, and the amount of money I spend on plants, foliage, dirt plus foliage, the money has got to be less than $100. So, our inequalities, know what I'm going to do is I'm going to make my axes right here, because this is all positive. So, let's let the y-axis be right here. Let's let the x-axis be right here. Okay. Let's graph our two easy inequalities. I'll do the y has got to be greater than 5, so I know, or equal to, y has got to be above that red line. X is greater than 0, of course, so it's everything to the right of the blue line. Okay, and now let's take our last equation. 4x plus 10y is less than or equal to 100. We're going to put that in slope-intercept form. You guys go ahead and put it in slope-intercept form. Okay, you should have found, when you solve this inequality, for y, we get y is less than or equal to negative 2/5. That's a 5, folks, sorry. Negative 2/5 x plus 10, which when I graph that line, it looks like this green line right here. Okay, and that's actually going to be shaded below this green line. So our region of possibilities is going to be bigger than y is 5, bigger than this red line going up, to the right of x equals 0, the blue line, and less than this green line. The region that meets all the criteria is this section right here in yellow, this little triangle. So any ordered pair in that triangle is the number of bags of dirt and flowers, plants, that Abby can buy. Hey, that's it, folks. Have a great night, and we shall see you soon.